Assalamualaikum and good day. So I will continue with our gyroscope lecture. So I ask you to think how the gyroscope is not falling even though the shaft is in a horizontal position. So it looks like it is defying the gravity. So have you think about it? So make sure that you think and hopefully you got the answer. But anyway, I will finish our lecture in this video. So then we have covered this, and actually I have one video that I want to show you, but you can find this in YouTube, where there's a guy or a lecturer who will spin this this wheel. Look at the picture in the video where the shaft is tied or fixed in a rope, and then when the wheel is rotated by the person, it will not fall. The wheel will be in a vertical position even though the person has released the wheel rotating. So that is the gyroscopic effect, where the wheel will not fall, or in the previous in the gyroscope like this, it will not fall even though the shaft is in vertical horizontal position. So I will go into the details, into the equation today. So we have learned about this. So as I want to remind you that we have three angles that we are considering, or three axes. The axis is X, Y, and Z. And if you look at here, for X, it is the nutation, and for Y axis is the precession, and finally the axis of the disc of the gyroscope is Z axis, where we call it spin. And I've shown you a video relating to this, where when a wheel is rotating and we apply force, it will not move toward the direction of the applied force, but instead the face is like 90 degree from the applied force position. So that is the difference when the wheel is static and when the wheel is rotating. Where in rotating wheel, we have angular momentum. So we can skip this one. Okay. If you want to consider a gyroscope, or in this case we are using a top. I'll show you this one. Okay, this is the top, or in bahasa Melayu is gasing. So if you want to consider it consider the angle and the rotation, we need to use this sequence. So we have large X, Y, Z axis, and we also small X, Y, and Z axis. So what is the difference between these two is X, Y, and Z. The big one is the original position, and the small X, Y, Z is the current position of the cousin axis of the rotation. So just bear with me with this sequence. Number one, we rotate the top about the Z axis through an angle psi. So if you look at here, this is actually the picture of the end of the sequence. So I will show you. Okay, this is the picture. So the first picture is the angle that we rotate about z-axis, and the angle is psi or precession. Okay, that is the first step. And the second step is we rotate the top about the axis through an angle theta. So if you notice, the x is small. So what happens is, if you look at the first picture, the due to the first step, the big x and the small x axis is not overlapping anymore. So if you look at the second picture, rotation about the small x axis will cause the angle of theta, which is we call nutation. So that is the second step. Notice the change in the y-axis also, where the y-axis has changed its position 2 times. And the last one is the third step. Rotate the top about the z-axis through an angle to obtain the final position. So this symbol is the symbol of spin. If you look at this picture, we rotate the top according to the y-axis. Sorry, according to the z-axis, if I'm not mistaken. Yes, again at the z-axis, and this time it's not similar with the big z, but we are using the small z, and that angle we call it a spin angle. And if we can calculate, if you look at here, we have a dotted symbol, 3 dotted symbol, and it is the speed of the or angular velocity for each axis, small x, small y, and small z.